What's up everybody, this is Jesse from VCC Board Repairs. In today's video, I have an iPad 5th generation that doesn't turn on because there's a short on the motherboard. And this is the first type of video where I cover how to find shorts. So make sure you stay tuned to the whole video because we're gonna show how to diagnose it, how to find the short, how to fix it. And I would really appreciate you guys if you hit that like button for the YouTube algorithm, subscribe to the channel if you want to see more videos like this. Share this video with all your friends in the repair world and let me know in the comments what you think, what other type of videos I should cover, whether it's repairs, tools, or anything else. And let's go ahead and get started with this video. Okay, so step one in the diagnostic process is to plug it into charge. Now, this iPad, when I would plug it into charge, did not show any image on the screen. This is the first sign that there's no power or there's an issue. Here on the screen is the USB charging meter. If I plug this in, you'll see the green number is the current. You see, I'll plug it in. There's some current flowing in, 0.63 amps. This is actually a pretty low charging current. Now, on iPads, when I have the battery disconnected, it shouldn't pull that high of a number, but we do see that number being pretty high. So usually you'll get about 0.1 or less with no battery plugged in. Right now we're getting 0.6. So this is the first step. Points towards there's an issue on the board. Now, second step I like to do is test with a Tristar tester. Now this is the ICC Pro from Rescue. Shout out to Ben P for sending this over to me. What you do is you plug it in first, and then you click the button to wake it up and start the test. Now, one thing to keep in mind is Tristar Tester runs through a charging port test, Tristar Test, and ICC Pro does a VCC Main test. On iPads, it does not support VCC Main, so ignore that result because it could be wrong. Now it is done and you see Tristar passed. VCC Main passed, but like I said, it's not a supported model, so ignore the VCC Main on iPad. On iPhones, it does test for that. On iPads, it's not accurate, but you can see we got a Tristar pass, so that means the issue is not Tristar, it is something else. So let's go under the microscope and do the next step. So here's where the fun starts. So what we got to do first is set your multimeter to diode mode. That is the little triangle pointing to the right. It will vary on multimeter on different models. Check your user manual if you're not sure. But put your diode mode, put it in diode mode. If you put them together, you'll see 000. That means short. So to test this is you put your red probe on ground. So like you put it here on the shield, and then your black probe, you want to probe around. Now I know off the top of my head on iPads, the caps, the capacitors around PMIC, which is this chip, is VCC Main. So if I probe any of these, you see I get 0.000. On the other leg, 0.000. Both sides should not be shorted. Capacitors generally have one side on ground and one side on a line. Here we have both sides on ground. So that tells us there's a short on the motherboard. Now, we do have ZXW, which is a software that allows you to view the different lines and stuff like that. If we look here, this is the iPad 5th generation on ZXW. You'll see all these caps around PMIC are red. So if I click on any of these, it's all the same line. There's a few other caps that are something else, but if you see a line that covers majority of the board like this is VCC Main on iPads. This is very true on iPad Air, Air 2, 5th generation, 6th generation, 7th generation, 8th generation. All the iPads are basically the same design, where there's a CPU somewhere else, which is a really large chip. PMIC is the second largest chip that's like a square. Now another large chip is NAND, which is this, which has a totally different look. So you should be able to recognize it because there's usually a bunch of coils right around that as well. So what you do is just click on any of these caps, any of these yellow lines, and if it lights up like majority of this area, that is VCC Main. So we go back to the microscope, You'll see this is basically what we're looking at. And if you probe any of these caps, you'll read it as a short 0.000 in diode mode. This is 100% a short. Now, one thing to keep in mind is when there's a short with the capacitor, like a short on a line, you cannot just probe and find the bad component causing the short. You have to find it by injecting voltage or somehow making the component stand out. And usually that is by injecting power to it. There's multiple ways to do it. The easiest way is on iPads is to inject voltage directly to the line. You could also plug in the charger sometimes and get lucky and get the component to light up. Sometimes you get really lucky and just find a burned component, but so far I don't see any obvious burned components. So I think we'll have to bring out my thermal camera and start injecting voltage to try to find it. So let's go to that. Okay, so this is my thermal camera setup. It is an iPhone with a Seek Compact Pro with my macro lens. Check out the link in the description if you need a macro lens. Also, if you want to buy a Seek, we do have these for sale at inyourgadgets.com. It'd be awesome if you guys can buy it from them. Show some support. Now, the stand is also a custom stand that I built. I will be building some more and be selling those as well. So stay tuned for that. Now, on the screen here, I will show you what you see on the iPhone. Now, right now I don't have any power applied, so you can't really see where the short is. But if you remember on ZXW, most of the short was going to be around PMIC. And I say that because we know VCC Main is shorted, and we need to inject voltage and find that shorted component. Now, the components that will be shorted will be the ones that were highlighted in red on ZXW. Now, what you do is set your DC power supply. For VCC Main, you could do 4.3 volts and set the current to, I have it to 2.5 amps. That means when I inject voltage to this line, it will inject 4.3 volts and it can pull up to 2.5 amps. Now, I do have these multimeter probes connected directly to my DC power supply through extension cables. So you see if I touch these together, we get 2.5 amp draw. Now, there's so much current that it does pull down the voltage, so don't pay attention to that. Just look at the amps, the bottom number. So you see 2.5 amps. Like, oh, 0. So this same behavior will happen when I inject voltage, because you're essentially touching these two together through the ground line, through the shorted component. So the process is pretty simple. Put the black probe on ground, so that's anything metal. So like either the top of the Wi-Fi chip here, this metal shield over here. And then what I like to do is find a capacitor to inject to. Now, we go back to the XW really quick. You'll see there's a bunch of places that are red. Now, the red probe injects directly into that line. So you could technically touch anything here on red, and in theory, the shorted component will light up in the thermal camera, because what happens is when something's shorted, all the current will shortcut from where it's supposed to go to that to ground, because the electricity wants to go to ground. So a capacitor is shorted, it pulls that line to ground, so it basically creates a kind of it's a shortcut from where it should go to ground. So one thing you'll notice is here next to Wi-Fi, there's these two caps. So the top side of these caps are VCC Main. Go back to over here. There's these two caps here. So what I do is just touch the top side of the cap, and then you'll see the shorted components light up. So I'm putting my black probe on ground, so somewhere right here, and then my red probe. It's going to be hard to show here on the camera. I'm going to touch that. So I'm going to touch VCC Main, And you'll see on the camera, there's something that lights up. See that component? And one of the great things about using a Seek Compact Pro with the macro lens is you can get up real close to the component and see. Kind of hard to see with iPads just because all the metal reflection does kind of trick the camera thinking it's heat, but you should still be able to spot the component. So let me do it one more time. You see that lighting up? I'll let go, touch it again, lights up. Now let it cool down a little bit. You can see clearly is this component here that is lighting up. So looking through the thermal camera, it was this component here lighting up. So this is the short. That is this component here. Appears to be a capacitor because it has one leg on ground. So let's go ahead and get this removed and test again to see if the short is still there. Okay, so this is the component that's shorted. Let's get this removed. So what I'm going to do is use my hot air. I'm going to get some flux. Both sides. I'm going to use some low melt solder. Since iPads are really large boards, they do soak up a lot of heat and it is a lot harder to melt solder. So this low melt solder does help with, oh, can't reach it. Let me try my micro pencil. Let me try the micro pencil. Looks like it's not taking in that heat. There it goes. I got a little blob of solder there. So what I'm going to do is get my hot air. See if I could assist my micro pencil, which is very weak as far as transferring heat. But the tip is really small, so it allows me to get into little small crevices. Look at that, I was able to lift it with just my iron and hot air. Alright, I got this off. There you go, it's removed. So, before I do anything else, let me clean up this area a little bit. I'm just gonna apply some solder on both sides. Also, let's see some solder, spray solder, but I was able to pick it up with my iron. Now let me clean this area. Okay, so I'm just cleaning off all that extra flux. So now that potentially shorted component is gone. I actually have it right here. So what we can do is we could actually measure individually this component. Let's see if we could detect if it's shorted. So what we do is get our multimeter. Same process as we get diode mode, and then we probe both sides. You see we got continuity across it. Now this appears to be a capacitor, which means we should not have continuity across it because capacitors do not work that way. They're just different types of components. So now let's check on the board as well. Now if you remember, originally I probed some cap over here. Look at that. I now have 153 on my multimeter. On one side, 0, 0, 0 on the other side. This is true for all the VCC main caps here. Even this, where I remove the large capacitor. But because this is a large capacitor, what I'm going to do is just replace it. Okay, so this is an iPad Air 1 donor board. There's a very similar capacitor here. So I'm just going to go ahead and use my hot air to remove it. Alright, so I'm going to turn up my hot air a little bit. This is a donor board, so it doesn't really matter if I overheat it. So I'm at 420 with 110-ish air. Let's just heat up the area. Alright, it's loose. I will remove it. Move this board out of the way. Put back this board. And you'll see it's very similar. Now the part numbers are slightly different, so the value might be a little different, but let's see. Let's see if this solves it. Unfortunately, with iPads, there's no schematics or documentation. All we have is the board view, which is very vague. There's no information with it, so we can't be 100% sure on component values. We could just use best guesses, and oftentimes Apple just reuses the same design, same components, so it should work. Alright, so I've turned down my air to 400 Celsius, 80 air, and because I use low melt, that installed super quick, and should be good. Let me just clean this off a little bit. Also, just putting the ISO does cool it down a little faster, especially when I'm heating it here with some the little hand pump that I like to use. All right. Okay, so now that we've cleared the short on VCC main, we replaced the capacitor because that capacitor is really large. So I figured it's pretty important. In other cases, one of the smaller capacitors, you can actually leave it out. In most cases, it should be fine. So now that we have, that fixed, what we're going to do is run through the exact same test and compare the results. So previously, when you plugged it in, you got 0.6 amps. Now, plug it in, we get 0.06, 0.07, 0.15. So you can see in the graph, it slowly kind of works its way up, but then it comes down, goes up, comes down. So this is a way different behavior than before. We're no longer getting a solid fixed 0.6. We're now getting like a small little jump. This is a good sign. This tells us that the board might be functioning. So let's go and do, what I'm going to do is reassemble the iPad and then test again to see if it boots up. Okay, so now I have it partially reassembled. I don't have it all screwed down, just the battery, have the LCD plugged in, the digitizer plugged in. What we're going to do is now compare plugged in battery, plugged in screen, and you'll see the USB charging current goes all the way up to 0.6, 0.5, and we have an Apple logo. And then you should see the charging current go up even higher. There you go. So you can see the behavior is way different now as well. We have a charging current at over 1 amp. That's a good sign. That tells us it's charging, it's functioning. We have an Apple logo. So any second now, we should get to the lock screen. Oh, look at that. Turned on. iPad, there's touch. Here in the top corner, you'll see 100% battery. So this is a fully charged battery. Everything's working, and we're good to go. So I think we're fixed and it's ready. All right, guys, there you have it. iPad is now fixed, fully charged, everything's working, and we have a successful repair. So I really hope you really learned something from this process. Now, every scenario for a short will be different. Every no power situation will be different. It's not always going to be the exact same component or the exact same short, or sometimes you have no power and it's something else. So that's a whole different other topic. But if you have this exact scenario where you find the VCC main short, you know what steps to do. Basically inject voltage to find the shorted components. Thermal camera, super helpful because super quick to spot the component that heats up, and it costs nothing, just the initial investment of purchasing the equipment. Now, there's other ways to do it with freeze spray or canned air. Now, those are consumables, so you will have to keep buying. Sometimes you get in a pinch where you run out and then you can't really, find the short component. So, I like the thermal camera. In total, I probably spent about $700. Thermal camera, the macro lens, the tripod stand, the phone that I use for that testing. So it was well worth the money. It's paid off in the time saved. A lot of data recoveries. I use a thermal camera to find these shorts. So definitely recommend one if you do this professionally. If you do this as a hobby, then maybe stick with freeze spray or compressed air, something like that. Now, do appreciate you guys sticking to the end. If you made it this far, let me know in the comments. Subscribe to the channel, like the video if you haven't already, and I think that's pretty much it for today's video. See you guys next time. Hopefully within a week, I'll have another video. All right, peace out and keep on soldering, guys.